Welcome back again. Thank you for joining me for our 2.7 notes. Today we're going to be talking about absolute value functions, and our objective is to be able to graph these functions. So to begin, we need to just get a general idea, what is the parent function of these absolute values? So when you just have f of x equals the absolute value of x, you are getting this graph right here. It looks like a giant V. And basically what ends up happening is you create two separate lines. One when you have x is greater than 0, the other when you have x is less than 0. Now, just like a parabola, you may remember the term vertex. The vertex is going to be that point where it splits, all right? So our first task when we're talking about these absolute value functions is we want to know, where is this vertex? Now, this vertex obviously changes based on the transformations of the parent function. So what I'm going to do, I'm going to express the parent function with a transformation. So if we take an absolute value, and let's say we end up moving it horizontally, and we end up moving it vertically. So let's say that is our function. We have a vertical shift and a horizontal shift. Our vertex is going to be shifted as well. So now remember, this negative right here in this equation, that negative means it's moving to the right. So if you see an x minus some number, well, the x value of the vertex is going to be positive, because remember that negative is shifting it to the right. And our y value of the vertex, that's going to be shifted up by this k. Now you may recall seeing this in terms of quadratics. Well, the same thing holds true for absolute value. If you have a vertical and horizontal shift, this ends up being where your vertex lies. And then what is the equation for the axis of symmetry? Well, I want you to notice axis of symmetry is going to be a vertical line. And as we already discussed, a vertical line will always have the equation x equals the number that it's at. So if we're talking about the equation of the axis of symmetry, it's going to be x equals that h value, all right? That's where that is going to lie. And just like a parabola, if you can graph half the function, then you'll be able to graph the other half. So in terms of graphing, in order to graph these, we need to find the vertex first. Once you have the vertex, you can plug in a couple points on each side of it to get the slope of each side of the V. So our first task every time is going to be to find that vertex. So I'm going to start with example 1. And this ends up fitting exactly what we just wrote down. I'm seeing a horizontal shift, a shift along the x. So because that it is being subtracted because it is negative, that means it's going to be a positive x value. It's moving to the right. And then also notice it's being shifted up. So that is where our vertex is going to lie. Our vertex is going to be at 3, 2. So that's going to be the first thing that I plot on this graph. I'm going to plot that 3, 2. Right. And now, just like how I drew in green up on the first one, that axis of symmetry, I'm also going to draw the axis of symmetry here. Because when we put one point on it, on one side, we should be able to mirror that point on the other side. Now, I'm going to start taking values on either side of that, that vertex, that 3. So I'm going to start with 2 and 4. Okay, so I'm going to erase this, and I'm going to evaluate my function at 2 and at 4. So I'm going to start with 2. So I'm going to put 2 in for x. So I get the absolute value of -1 plus 2. Well, We know the absolute value of -1 is +1, so we end up getting 3. And now, just to show you what I mean by the fact that it is mirroring, so I'm going to do 4 now. 4 minus 3 plus 2. Well, now we get the absolute value of 1, which we know the absolute value of 1 just stays 1. We get that same 3. Okay? So what ends up happening is we get this point and its mirror point right there. If we go another point along here, so let's try another one of these. I'm going to do 1 and 5. So I'm going to plug 1 in. 1 minus 3 plus 2. So we get the absolute value of -2 plus 2. Well, absolute value will make it positive. So 2 plus 2 will just equal 4. Let's try the 5. Let's make sure we're getting the same thing. 5 minus 3 plus 2. Well, 5 minus 3 is just 2. Absolute value of a positive number doesn't change it, so we just have 2 plus 2, or 4. And we're in luck. We did end up getting the same thing, just like we were supposed to. So I can plot those points, 1, 4, and 5, 4. And notice, the points are still mirroring each other across that line of symmetry, and we're getting that V shape just like we were expecting. So I have enough points that I feel confident that that is my graph. Those are the 2 lines that I get. So this is a process we're going to follow whenever we're graphing these. Find the vertex, then start finding points around the vertex. So, oh, I apologize, went too far. So, graphing y equals 4 times the absolute value of x. Now, for this one, I want you to notice, I don't see any horizontal or vertical shifting, okay? So what that means is our vertex isn't moving. Your vertex always starts at 0, 0, and it only moves if you have a horizontal or vertical shift. At this point, we don't have any. All we have is a stretch. So I'm going to put my vertex on right away. And it's difficult to see, but I'm also going to put in that line of symmetry. So I'm going to start finding some points. So 0, 0, we know is our first point. We start at that vertex. And now I'm going to start finding points around it. So I'm going to do -1 and 1. So let's start putting that in. 4 times the absolute value of -1 is really just 4 times 1, or 4. Let's make sure we get the same thing. We know we should get the same thing by using that 1. Well, the absolute value of 1 is just 1, and we do end up getting that same 4. Okay, so those are going to be the next 2 points that I plot. 1, 4, and -1, 4. So I'm going to try 2 more points. I'm going to move on to -2 and +2. I'm just working my way around the x values of my vertex. So 4 times the absolute value -2. Well, absolute value -2 makes it positive. So 4 times 2 gives me 8. And let's make sure we're getting the same thing on the other side. So 4 times the absolute value of 2, well, absolute value of a positive stays positive, and we just get 8 again, just like we were supposed to. So that's going to be the next 2 points that I end up plotting. And now, I do believe that is going to be enough points to see we are getting that proper V shape. All right? So I can be done plotting points. And I'm just going to leave it at that. For example 3, we're discussing the same thing again, where we have a situation that is no horizontal or vertical shifting, okay? There's only that stretch. So what that ends up meaning is our vertex is going to start at that 0, okay? It's going to start at the origin. And I'm going to put in my line of symmetry again, so I know that that is where my line should be mirrored from. So I'm going to start my table, 0, 0 in the middle. Now this time, to make it convenient to graph, I'm going to choose some smart points, all right? So I know I'm going to be multiplying this by 1/3. So I'm going to try to intentionally choose numbers that make that doable, okay? So what I mean by that is I'm going to choose -3 and +3. All right, those are going to be the first two that I'm here. You could do -1 and 1 just like we have been, but those are not going to be easy to plot on the graph, and I'll show you why. When I plug in -3, we know it becomes positive. So 1/3 times 3 gives you 1. Now, let's check to make sure we get that on the other side. Absolute value of a positive stays positive. 1/3 times 3 gives you 1. So I want you to notice it took stretching out to that -3 and 3 so we could get a whole number y value. So again, you don't have to do that. You could have continued our x's just like we were before, but to make this convenient to graph, I'm going to choose numbers that give me integers when I have to multiply by 1/3. So that means my next ones, I'm going to choose -6 and +6. So let's see what happens when we choose those. Well, I'm going to plug in 1/3, absolute value -6. Well, we know the absolute value of a negative makes it positive. Oh, so I'm going to multiply by 6. 1/3 times 6 gives me 2. Do the same thing for +6. Well, we know that taking the absolute value of a positive leaves it positive. So we end up getting 2 as well. So I'm going to plug in those 2 points. And again, with those, we can see that we have our shape. We're getting the V that we are supposed to. So I'm going to stop plotting points and make my arrows. Last one for the notes today. This is the same situation once again. What I'm seeing is that I don't have any vertical or horizontal translation. So that means I'm going to start at my origin. I'm going to put in my line of symmetry. I'm going to start choosing points. So we're starting at 0, 0. So -1 and 1. So we have -4, absolute value, -1. Well, absolute value will make that 1 positive. So we'll have -4 times 1, or -4. Now let's do that on the other side to make sure we're getting the same thing. So absolute value of a positive just stays positive. So -4 times that +1 is indeed -4. So I'm going to go over 1, down 4, over 1, down 4. All right, let's try -2 and 2. So plug that in. -4, absolute value, -2. Well, the absolute value makes that 2 positive, so we have +2. -4 times 2 is -8. plug in the positive 2 for the positive side. Well, absolute value of positive stays a positive, and we get that same -8. All right, so we're happy again. We got the same value for both of them. Now, unfortunately, this time our graph doesn't go down far enough. Now, we do know it would be somewhere down here, just like this, okay? But I think that means we can be done choosing points. Once we get off of our graph, well, we're kind of out of points that we're able to plot. So I'm going to connect these up and call my graph good. That is as far as I'm going to take this first half of our note video. So thank you so much for joining me. Make sure you have all 4 of these examples written down and then come to class prepared to do the practice work.